So for adaptation gap and climate finance, I'm going to just run through few figures from the UNEP report on adaptation gap, which is very similar to the emissions gap. So this is looking at the status of adaptation planning worldwide as of 5th August 2021, so very recent, prior to the COP26. So you can see that large part of the world has some national plan, strategy, law or policy in place for adaptation, climate adaptation. As I said, it is either for protecting against sea level rise, extreme events, health, air quality, and so on and so forth. But there are still many places where there has been no progress for planning, strategizing, developing laws or policies for such a thing. And there are places where no such thing exists, including in the Middle East, Central Western Asia, parts of Africa, and South America. Hopefully this will continue to change. Of course, there are also issues of whether countries can even afford it. So adaptation finance needs by sectors based on 26 developing countries' nationally determined contributions and national adaptation plans. Agriculture, infrastructure, water. As we said before, water is always going to be a critical issue. So this is the adaptation finance needs percentage of annual total. Disaster management. So these are climate adaptations. So against floods, droughts, energy, food, and so on and so forth. Forests and ecosystems, energy, coastal and marine resources, health and tourism, and other sectors here as well. So if we look at geographic distribution of principal adaptation projects funded by the top 10 bilateral donors, you can see that the global south is largely involved here, with some Eastern European countries and Asian countries, which are all essentially developing countries. So the top 10 bilateral donors are, of course, developed countries. Number of principal adaptation projects funded by the top 10 bilateral donors. The scale is here. So China and India, for example, have in the range of more than 50 or 20 to 50. Large parts of Africa also has many such funded projects. South America, Mexico, Central America, and MENA, Middle East and North America. So you can see that there is zero such adaptation projects funded in Russia and into Western Europe here, Eastern Europe, sorry. And looking at a map similar to what we looked at for emissions gaps, these are adaptation outcomes based on information published in the IPCC AR6 cycles, assessment report 6, that is being released now. Special reports on land and ocean cryosphere part. We are looking at the risk level here, going from undetectable, so it's not necessarily small, but it's not detectable right now. Moderate, so detectable with at least medium confidence. Significant and widespread impacts, and very high probability of severe risk and significant irreversibility or persistence of impact. So some region may become totally dry and unsuitable for agriculture, for example, may become too hot to live in, and so on. So you are looking here again at warming scenarios, at the low emission scenario of RCP 2.6, which would keep us below 2 degrees C with 67% probability, and high emission scenario, which is our business as usual, RCP 8.5. The adaptation scenarios here, these color scales include: dark colors represent risk level under no to moderate adaptation scenario, and these faded colors represent risk level under maximum potential adaptation scenario. So note here that present day refers to reference periods used in the underlying IPCC assessments 2006 to 2015 in the Land Special Report that was released in 2019, and 1986 to 2005 in the Special Report on Oceans and Cryosphere in 2019. Okay, so this is going from the present day to the end of the 20th century. High emission scenarios will increase the risk level the highest. So risk reduction achieved under maximum potential adaptation would bring the risk from very high to in the range of moderate to high. Is that good? Well, that's still an adaptation gap to reducing it to moderate risks or baselines of present day risk here. Under low emission scenarios, you would go by 2100 from here on a trajectory to reach again moderate to high risks, but with adaptation here, looking at the adaptation scenarios, we can bring it down to a moderate risk with some residual risk, which is kind of the adaptation gap. And here you are looking at maximum potential adaptation scenario, which would reduce us from high emission scenarios of high risk or high to very high risk down to basically moderate risk or undetectable or residual risk, as it's called here, in terms of a baseline risk that is computed for today. Okay, so this is what the there are lots of details on how these are computed, and there are tables provided for how this is done. This is not as simple as what we did with emissions gap of using the near linear relation between accumulated carbon and warming, and then looking at how much room that gives us to 2 degrees C warming and so on and so forth. So much more difficult, which also means we have to look at more details, especially what is called maladaptation. I will show that next. Okay, so here we are looking at primary sectors addressed by bilaterally funded principal adaptation projects between 2010 and 2019. They include multi-sectoral, agriculture, ecosystem, water, and infrastructure projects. And in here we are looking at sectors identified as adaptation priorities in countries' most recent nationally determined contributions. Remember, the originally submitted nationally determined contributions under Paris Agreement are deemed insufficient to meet any of the global warming targets like 2 degrees C. So each country is required to submit a revised NDC, and some are still submitting their first NDCs. So here you are getting again projects under agriculture, which dominates as opposed to bilaterally funded principal adaptation project here. So they plan to focus a lot on agriculture and water and health, and then ecosystems and infrastructure and transport. So you can see how the priorities change under the country's own NDCs. Okay, so sectors are marked in the same color in both panels so that you can facilitate, you can compare easily. The bars in panel A add up to 100% because each project was assigned to just one primary sector. In the bars in panel B do not add up to 100% because each NDC mentions multiple sectors. In panel B, each bar shows percentage of NDCs mentioning a particular sector out of all NDCs, counting the most recent one per country. Okay, so what do we mean by maladaptation? Here, a simplified continuum of adaptation outcomes from irreversible maladaptation to transformative adaptation. Let's say you decided based on projections that you are going to move water from place A to place B, and this results actually in moving water from a low water area to high water area, and just worsens the situation in the low water area, and improving the situation or not doing much in the region that has more water now. And the infrastructure built may be so heavy and so costly that it may be irreversible. I'm just saying here. Looking at the spectrum from worst to best, looking at the outcomes and examples, under maladaptation, you have target population irreversibly more vulnerable to climate change. So higher vulnerability to climate change than before, and the nature of vulnerability is new or different, something that they hadn't seen before. Choices made lead to pathway lock-in that determines future adaptation opportunities. Okay, so sometimes this becomes like a zero-sum game. So if money is put into afforestation and that makes agriculture very vulnerable, then it may turn to be some irreversibly more vulnerable populations. Examples include smallholders sell land when the value is nearly worthless due to climate pressures. They quit farming and move into wage labor in a climate sensitive sector, meaning that loss of employment is likely in the near future. Okay, target population more vulnerable to climate change but still flexible. Other groups adversely affected by strategy. So here again some details exist. Examples include smallholders maintain land but engage in seasonal wage labor elsewhere, so they can reverse to doing agriculture if necessary. So opportunities to improve farming conditions are missed, and making changes to livelihood strategy is costly or impossible. Here, higher new vulnerability is introduced, limited or no options for addressing new vulnerabilities offered. So in this case, examples include irrigation is developed that extends life of farming practices in the target location. However, this creates significant water stress downstream, leading to new climate change vulnerability. Such issues are being played out in shared river waters, riparian agreements that have become outdated, climate change adaptations leading to adversely affected populations, sometimes not intended, sometimes not taken care of. Okay, so slowly moving towards effective adaptation. There are also ineffective adaptations, but under effective adaptations from worst to best, you have short, medium-term effectiveness, no negative consequences in the long-term positive impacts, and transformation to climate resilient pathways, which is the best case scenarios. Here examples. Small-scale irrigation is developed for farmers, but climate change continues to pose a significant challenge for agriculture. This is happening a lot in China, India, Africa, even US and Europe, for example. Here, mediation groups with upstream, downstream users are established to help create sustainable quotas for water uses, making everyone happy and building social capital. So that's a long-term positive impact. Under transformation to climate resilient pathways, example is few or no real-world examples exist. This is an ideal outcome. Okay, so that's your adaptation gap. Okay, so here countries including selected adaptation interventions in stimulus packages as at 31st January 2021. What are we talking about? Basically, COVID came and 2020 wiped out many economies and brought many economies to the brink. So many countries started to develop stimulus packages for 2021, and many people have been watching very carefully to see whether stimulus packages are geared towards sustainable methodologies, adaptation friendly investments for, let's say, transportation, agriculture, health, and so on, or they are just focused on kicking the economy into full gear with full consumption of fossil fuels, full increase in emissions, and so on. So the little dip that was seen during COVID is now basically back to normal as it was before COVID. So this shows that countries that included selected adaptation interventions in this case just focused on adaptation. So climate risk integrated plans were done in some countries in Africa, South America, Nepal, Bangladesh here, and this is where are we? Philippines and inside Japan, whoever that is. We have to go and is that Korea? No. Yes, that must be Korea. Okay, so anyway, a figure based on the same sample of 72 countries described before. Basically, it means that very few countries paid attention to adaptation or sustainable goals or reducing emissions when it came to financing the stimulus to recover from COVID effects. Okay, synthesis of progress and gaps in adaptation at the national level as reported in corresponding chapters of this report. Increasing climate risks, recent path to end of century. We already looked at this, going from RCP 8.5, 2.6 and hypothetical illustrative midway scenario. So this is again showing without adaptation for different scenarios and with adaptation, just to mimic our emissions gaps, and it looks at evidence of adaptation progress, identification of adaptation gaps, including adaptation finance, and factors that constrain the interpretation of findings. There are lots of barriers to adaptations as well, institutional barriers, knowledge barriers, and so on, which a lot of articles are written about. In this context, I just wanted to include it as something that is going to be a big part of the budgeting for the future. Mitigation is about renewables, EVs, reducing emissions and so on, but adaptation may be just inevitable for many countries that are facing consequences already, so that has to be considered seriously in climate economics. Okay.